Hi guys. Today what we're going to be doing is we're going to be focusing on Newton's laws of motion. Sir Isaac Newton was a very smart man. He basically, if you've ever taken a look at physics books or ever take a look at a physics book, you will see a whole bunch of math equations. And basically, Sir Isaac Newton is the one who came up with most of those math equations. A very brilliant man, but he made many observations and started noticing patterns and principles that developed into Newton's first, second, and third law of motion. And so that's what we're going to be looking at today to help us understand the science behind our egg drop experiment, as well as the science behind our problem of trying to innovate bike helmets. So what we're going to be doing today, we'll take a look at Newton's first law. Newton's first law basically states that any object in motion will stay in motion unless it is acted upon by a force, or any object at rest will stay at rest unless it's acted upon by an unbalanced force. And so let's say, for example, I take this golf ball and I go ahead and I drop it. You'll notice that it will go ahead and fall. It won't rest like it normally does, like it was resting in my hand. And the reason why is because here on Earth we have gravity as well as other forces that will go ahead and kind of impact our understanding of Newton's laws. So what we're going to do today is we're going to imagine that we're in a magical place. There's no gravity, there's no friction, and there's no air resistance. There we go. So now that we're in our magical place, imagine that we have that golf ball again. So I go ahead and hold the golf ball up, and it's resting in my hands. And if I go ahead and let go, it will stay right where it's at. That's what Newton's first law is stating, is that an object at rest, it will stay at rest. If there's no gravity or any other balanced force, it will stay just there. If I go ahead and press against it, on both sides equally, it remains there, just there. Now, if I were to go ahead and put a force on one side of it, like spinning it, you'll see it starts to spin. Now the second part, we're going to go ahead and get rid of that. The second part of Newton's first law states that an object in motion will stay in motion. So let's go ahead and get it's resting right now. Now if I go ahead and push it with a certain amount of force, you'll see that we'll go ahead and continue to move all the way across the screen. And it'll continue to keep going because once an object is in motion, it'll stay in motion until something causes it to stop. Now looking at Newton's second law has to do with acceleration. Now we've studied acceleration before, and so this should be something that's not new, except for we're going to go ahead and apply mass and force to acceleration. Now Newton's second law is sometimes best remembered with a mathematical equation. F equals ma. So this F equals ma will kind of help you understand, those of you guys who think in math terms, help you understand how force, mass, and acceleration are related to one another. So let's go ahead and imagine I have a Hot Wheels car. And I go ahead and put this Hot Wheel car right in, again, we're in the magic land where it stays there. And I go ahead and apply a little bit of force to it. And you'll see that it will go ahead and it will accelerate. That force caused that object to accelerate in the same direction that the force was applied. Now let's go ahead and imagine that this time I take a Hot Wheel car that's much, much bigger, therefore has a lot more mass, and I go ahead and apply the same amount of force. You notice that it will accelerate at a much slower rate than the other car did. The more mass something has, the less it will accelerate if it has the same amount of force as something that has less mass. And so let's say, for example, I go ahead and take the same Hot Wheels car, the small one, and I go ahead and place it there, and again, it's no gravity, and I go ahead and this time give it a lot more force. You'll see it accelerates really quick. So if I change the amount of force, it changes the acceleration of the object. If I go ahead and change the mass, it also causes the acceleration to change. So it's one of those things where there's a relationship between force, mass, and acceleration. Now let's look at Newton's third law. Newton's third law is known as the action-reaction law. That basically states that for every action there's an equal and opposite reaction. Now imagine that you're in PE and you got your brick wall. And if I were to go ahead and push on that brick wall with a certain amount of force, that brick wall is going to go ahead and push back with the same amount of force as I pushed against it. Now that seems kind of silly, but I want you guys to imagine if you had your roller skates on in the gym class and you're going ahead and you're pushing against that brick wall. You'll go ahead and be pushed back with the same amount of force, and you'll move that back that far, that distance. That's really going ahead and giving you an idea that for every action there's an equal and opposite reaction. A way to go ahead and understand that with Newtonian physics is understanding how airplanes and jets fly. So imagine that we have an airplane or a jet, and again we're in our magical land where it's able to float into space, and we go ahead and move it and change it a little bit. And imagine that, in order for a jet to work, it has to go ahead and use all that gas and then go ahead and push out the energy airplane, and it moves and causes it to move in the opposite direction. So that's that equal opposite reaction law that we're trying to go ahead and get you to understand. Those are Newton's 3 laws. We're going to be going ahead and using those laws to help us understand the science behind it, so we need to make sure that you have those notes taken, and we'll be using those in class and being able to apply it. If you happen to have any questions, make sure you ask me, and we'll see you in the next couple days.